Hello everyone, welcome back to my organic chemistry mini lecture again. Today the topic will be the electrophilic addition. So this is a very general type of organic reaction including halogenation, hydration, hydroboration, oxidation, hydrogenation, a lot of reaction. But today we will just talk about two of them. That is the hydrohalogenation and halogenation. Okay, so we will also use two different type of substrate, the alkene and alkynes. Both are unsaturated hydrocarbons. So we will first talk about the hydrohalogenation of alkenes. And again, today we will focus on the arrow pushing mechanism. Okay, this example here, this is the propene and react with hydrogen bromide, and the product is saturated alkyl halide. Okay, for this example, it's a 2-bromo propane. The mechanism shown here, first step is the pi electron from the double bond actually will attack this proton and kick off the bromide as a leaving group, so breaking the hydrogen-bromine bond. This step called protonation. After protonation, the intermediate will be the carbocation intermediate, and this is the secondary carbocation. And actually, this carbocation formed is this terminal vanillic carbon take the proton, the other internal vanillic carbon will be positive charge. If this internal vanillic carbon take the proton, then the terminal vanillic carbon will be positive charge. And that is another possible intermediate formed as a primary carbocation. And secondary carbocation actually is more stable than the primary carbocation. So the second reaction will not happen. And so this secondary carbocation will react with the bromide, which is from the first step as a leaving group. And this bromide actually is the nucleophile now, and this carbocation is the electrophile. And then nucleophile attack the electrophile. This is the nucleophilic addition, and form the new carbon-bromine bond here. And the product is actually a saturated alkyl halide, the 2-bromo propane. And look at the intermediate, it's a carbocation, so you always have to be careful, watch out the possibility of a carbocation rearrangement. The requirement is you need to form a more stable carbocation. So if that possible, you have to draw the more stable carbocation. And there are two types of carbocation rearrangement, 1,2 hydride shift or 1,2 methyl shift. And so then the major product should be generated from the more stable carbocation. But in this example, we don't have that carbocation rearrangement happen because you cannot draw a more stable carbocation after 1,2 shift. Okay, now let's look at the hydrohalogenation of alkyne. So that's the hydrocarbon with triple bond. Now the example here is the propane, and this is actually a terminal alkyne. Okay, so and react with the hydrogen bromide, same reagent, and the product will be dibromide. It's actually 2 bromine connect with the same carbon, so it's called a geminal dibromide. Look at the mechanism will be similar with the hydrohalogenation of alkene. First step is the protonation. So the there are 2 pi bonds, but the 1 over pi bond electron will attack the proton here and kick off the bromide as the leaving group, and the intermediate will be a vinyl cation. It's not very stable carbocation. And then the bromide will be the nucleophile, which is from the first step, will attack this carbocation and form a new carbon-bromine bond. This new bond formed. Now you can see this is actually a vinyl bromide. It's an alkene, and you still have a pi bond and the pi electron can do further protonation and kick off the bromide, and then you make this carbocation intermediate. And this carbocation is a good electrophile, will react with the bromide from the last step, and the nucleophile will attack the electrophile to form new carbon-bromine bond, and that is the final product, the 2,2-dibromopropane. Okay, that's a reaction of alkyne with the hydrogen bromide. It can also react with hydrogen chloride, so that's the mechanism. Okay, we will talk about the halogenation as the second electrophilic addition. So react with alkene, they will generate a dihalide. So if you use the propene react with the bromine molecule, then the product will be a dibromide, but now this is called a vicinal dibromide because these two bromine connect with the two different carbon, and that two carbon are neighbors. So 1,2 position. Now look at the mechanism here. First step is the pi electron attack this one of the bromine, and the other bromine will be kicked off as a leaving group. Okay, so break the bromine-bromine bond, and the lone pair on this bromine will actually attack back this vanillic carbon. Okay, form a cyclic intermediate. It's called bromonium. Bromonium is a cyclic positively charged intermediate, and from first step, the bromide, the leaving group, actually now will be the nucleophile. It can go back to attack this carbon and break the carbon-bromine bond, basically open this ring, the three-member ring. And then the product is this 1,2-dibromopropane. It's just mentioned, it's a vicinal dibromide. Now, if you go back to this step, you may wondering why the bromide attacked this carbon, not the other carbon. It's because you can draw the resonance structure of this intermediate. If you pull electron of this sigma bond to the bromine, you will draw this secondary carbocation as the one of the resonance. And you also can pull the sigma bond back to the bromine, and you can draw the other primary carbocation. And secondary carbocation is more stable than the primary carbocation. So this resonance will contribute more to the average structure of these three resonance. That's called a hybrid. So this carbon, which is this carbon, will have more partial positive charge than the other carbon. So this carbon will be more electrophilic. That's why the nucleophile actually will attack this more electrophilic carbon. That's why. Okay, so if this reaction has some trace amount of water, then the product will be different. If you look at this reaction, I just show the bromine molecule here. So usually you should use dry organic solvent. You don't have water. You should not have water in the solvent. If you do have some trace amount of water, the reaction will give you different product. If you have a little bit of water here, the product will be halohydrin. For this example, it's a bromohydrin. Still same substrate, the propene, and react with the bromine molecule with water, you will form the 3-bromo 2-propanol as a product. It's called halohydrin. Mechanism, first step is the same as the last slide. So the pi electron will attack the bromine and kick off the other bromine as a leaving group. And the bromine also use a lone pair attack this vanillic carbon to form the bromonium as the intermediate. Now, instead of using bromide as a nucleophile, we have water. The water as a nucleophile now will open this ring. And the same reason, this carbon is more electrophilic. That's why this nucleophilic addition will happen to here and break that carbon-bromine bond and to form the protonated intermediate here. And then next step will be the base depronate proton. Take the proton and push the sigma bond back to the oxygen. The electron go back to oxygen, neutralize the carbocation, sorry, not carbocation, the positive charge. And then product is formed as this bromohydrin. So that's the three-step mechanism of this formation of halohydrin. Okay, halogenation of alkyne will produce a different product. You can see this reaction. This is the propyne react with the bromine molecule, and the product will be tetrabromide. Okay, so it's a saturated alkyl halide. And let's look at the arrow pushing mechanism here. The first step is similar with the alkenes reaction, and the pi electron from this triple bond will attack this bromine, break this bromine-bromine bond, and kick off this another bromine as a bromide as a leaving group. And then the electron of the bromine will attack back to form a cyclic positive charged intermediate. Similar with the bromonium, but this time it's called bromidinium. And then the bromide from the first step will be nucleophile, will attack this carbon and open this ring, and to form this dibromide. It's alkene. So you still have another pi bond here. So that can still react with the bromine molecule. The pi electron do the same thing, attack this bromine, kick off the bromide, and this bromine will attack back to form the normal bromonium intermediate. We saw this many times, right? So, and this bromonium will react with the bromide, which is from this step as a leaving group. Now it's a nucleophile. The nucleophile will attack this carbon, open this ring, and open this ring, form this product, which is 1,1,2,2 tetrabromopropane. Okay, so this is the step-by-step arrow pushing mechanism of this halogenation of alkyne. If you have any questions, please let me know. Okay, good luck.